Everybody, today we will discuss the cumulative scheduling problems and a new type of constraint for solving this type of problem related to cumulative scheduling. So the problem of scheduling, as you already know, is the problem of allocating scarce resources to activities over time. This is a very general definition. And one asset of constraint programming is that we can solve a lot of different types of scheduling problems with just one type of constraint, which is the cumulative constraint. So CP is very flexible. It contains a lot of abstractions for scheduling. So we have activities, building blocks, we have resources constraint, and we can also infer a lot of deduction with this kind of scheduling constraints to prune the search tree. So it's really a good asset for constraint programming for solving scheduling problems. Some examples of scheduling problems. So for example, the file download problem from observation satellites is one scheduling problem. So in that case, you have jobs. The jobs would be files that you want to transfer from the satellites to the Earth. And you have resources that limits what you can actually do in terms of file transfer. You have the download channels that will limit the number of simultaneous downloads. And you also have memory banks, which means that you cannot download two files stored on the same memory bank simultaneously. And the objective function is you may want to download as much data as possible within a given time window, because a satellite is moving around the Earth, and so you only have a limited time window to make this possible, the download file transfer. In planning problems, you also have scheduling problems, like if you remember the Philae one, which was the robots that was in charge of conducting experiments on a comet. The resources were the batteries. You have a limited threshold on the instantaneous energy consumption, and you also have a limited. You also have resources on the memory, because the file transfer are only possible when Rosetta is visible from the Earth. And the objective is maybe to maximize the lifespan of the batteries. Train scheduling. So the trains, when they arrive in a station, are moving in tracks like this, and they have exchange points like these ones, okay, or simply points. And the goal is to maximize the train's throughput on the time window, but you have limited resources, and obviously these are the track segments. You cannot have two trains because you want to avoid accident within the given track segment. And the jobs are the trains that are moving in the station. Steel production. So when you produce steel, you will actually schedule inside, during the process, you will move pockets of molten metal that we call a heat. And the heat is represented here as a rectangle, and so they will move from one step to the next, and every step requires given processing, like a converter, and then you have the degasser, and then you have the caster. Okay, and the goal is to minimize what we call the make span of the whole schedule. Minimizing the make span means finishing as soon as possible all the orders that you had to plan. Okay, and what you can see here is what we call the caster. It means that the molten pocket of metals are arriving here. Okay, and then we flatten them here inside walls, and we create. This is what the caster is about. So the caster step is this step.